So now that you've drawn your diagram and you have turned in your little piece of paper and your instructor has separated you into groups who have drawn very similar diagrams, I want to discuss what we see here. So what I've tried to get you to do here is to draw your first free body diagram. What is a free body diagram? It is a diagram of an object that represents all the interactions on that object. So, or what's interacting with that object, I guess I should say. So, for our hanging mass, hopefully you drew something to represent the object. So it can be a dot, it can be a circle, it can be a square, it doesn't really matter what it is, but you need to draw something to represent the object. Next, you want to put your interactions. Now, many of you probably thought that definitely there was a string that was interacting with this object. And hopefully you have drawn that string up here, okay? And some of you may have even included an arrow on that, and that's really great because the direction is really important for this interaction. The string is holding the mass or the object up, or holding it, it's pulling on it up. Okay, then maybe you recognize that, hey, there is something pulling on all of us, and you drew an interaction with the mass and the earth. And maybe you even put an arrow on it, and that's great. So the second thing to do is to draw the vectors So you've drawn the vectors representing the interactions. And third thing we need to do is make sure we label them. So here is a string, and that string is applying what we're going to call attention. And because the string is pulling, and a pull is also known as a force, I'm going to label it as FT. That's the force of the string on the object. And then down here, what keeps us from floating away, or what's pulling down on this object, would be the earth. And the earth exerts a gravitational pull, and I'm going to make that an F sub G for the gravitational pull. So now what is this vector business? A vector is a quantity that has both magnitude and direction. Magnitude means number or amount. And the direction is indicated by the arrow. So the string is holding the mass up. The gravitational pull of the earth is down on the object. And that is a free body diagram. So now what I would like for you to do with your group is to set up a ring stand so that you've got a spring scale here, and you can hook up mass onto the spring scale. There are a variety of different ranges of spring scales that we have, and we have a variety of masses. You just need to make sure that when you put a mass on your spring scale, that it is something that can be measured. So if it stretches the spring all the way down that's inside the scale, then you can't get a reading on there. So it cannot touch the bottom. So you'll have to pick masses that work. You're going to create a data table with your large whiteboard, and then you need to display that data in a useful way, and hopefully you have figured out what we like to draw or create in physics. So each one of these masses should be in grams, but But that is not the SI unit, so I want you to convert that to kilogram. And just to remind you, for example, a 500 gram mass, there are 1,000 grams in 1 kilogram. So that would be 0.5 kilograms. So now create your data chart with your kilograms. And we're going to measure the force. And the force should be measured in newtons. That's a capital M. This is for Sir Isaac Newton. And for right now, we're just going to leave it as this mystery unit, and we will discover what a newton really is soon.